We are asked to find the family of antiderivatives of this function right here. And what this is asking us to do is to find every function, we'll call that capital F of x, and this is pretty standard notation for antiderivatives. We're finding every function such that the derivative of this function equals little f of x, where little f of x is the function that was given. In other words, we're finding every function that if we differentiate, we would get this function right here. One thing that you might note is that the derivative of x to the fourth is 4x cubed. And that's great because that's exactly what we want for this first term right here. We want a function whose derivative is 4x cubed. So the first term in my antiderivative, which again is capital F, is x to the fourth. Now we can also recall that the derivative of x cubed is 3x squared. But that's not exactly what we want. We want a function whose derivative is just x squared without the 3 here. So how do we make that happen? Well, what you would do is you would just divide both sides by 3, or just put a 1/3 here. Then you can see that if you took a derivative of 1/3 x cubed, you would multiply by the 3 and the 3's would cancel and you would just get x squared. That's great because that is the function whose derivative is x squared. That's what we needed. So that is the next term in our antiderivative. We took the antiderivative of that piece and that piece. Last, we can recall that the derivative of negative 2x is just negative 2. The derivative of anything times x is just that thing. And again, that's what we want. We want a function whose derivative is negative 2. So the antiderivative adds the term minus 2x. Now for all antiderivatives, we can add whatever constant we want in here. Typically we just call that a big capital C. And now we've come up with a function whose derivative is the function that we were given. Let's check this thing. What happens if we take a derivative of this capital F of x? Well, we use the power rule. We get 4x cubed. In the next term, if we multiply by 3, we just get a 1x squared. The derivative of negative 2x is just minus 2, and the derivative of any constant is 0. So did we get back the original function? Yes, we did. So this checks out. So this right here is the family of antiderivatives of the original function. It's called a family because C can be anything. So this is an infinite number of antiderivatives of the given function. As sort of a bonus note down here, what is the derivative of x to the n plus 1? Well, the power rule says that you multiply by n plus 1 and you subtract 1 from the power. Now if we divide both sides by this n plus 1, we get that the function whose derivative is x to the n is just x to the n plus 1 divided by n plus 1. And this comes in handy when finding antiderivatives. Okay, I think that that's going to do it for this video.